Welcome to Chapter 1 of our PreAlgebra course. In this chapter, we will be learning a few things. We will learn about natural numbers. We will learn about whole numbers. We'll also learn what the term prime number means and composite number. These are very important definitions to know as you study PreAlgebra and mathematics as a whole. And then you also learn about variables later on in the chapter. It is important to note that there are different types of numbers, but the principles and operations we do with these numbers are very similar, but we just have to be aware of what these types of numbers are. In one of the courses I taught in the past, I saw a very good table. I believe it might have been a Saxon textbook from back in the day, where they had a situation like this, where you have real numbers, everything. So these are real rational, or just rational, you could just say. So rational numbers. And then over here we can have irrational numbers. So when you look at the types of numbers, you will notice that we have natural numbers, which are numbers like 1, 2, 3. You think of when people tell you their age, that would be like natural numbers. And then outside of that, we have whole numbers, which would be 0, 1, 2, 3, all the way moving up to infinity. And then you have another category called integers. Again, we'll learn about these later. Integers, and those include the negative numbers and the positive numbers of those numbers that we've talked about. So you have integers, natural numbers, whole numbers, and then you have rational numbers, which is really anything that fits into this category here that can be written in the form of something over something. For example, if you have 1 over 2 or 2 over 1, which is 2, but basically when you can write things in fractional form, we call those rational numbers, which would include everything that we have discussed so far with the whole numbers, the natural numbers, the integers, because negative 3 over 2 would still be called a rational number. So again, this real really belongs up there because it takes care of all of these. This is just one category here. Real numbers, we have rational, and then real numbers also, we have irrational numbers that can be considered real. Now, these are non-repeating decimals or situations like pi and e. You might not have heard of these yet, but just be aware that there are numbers that do not repeat, and we call them irrational numbers. So we've seen the different categories of numbers. In this chapter, our focus is on whole numbers. And we'll be talking about addition, subtraction, multiplication. It's just a good review for you as you study mathematics. The other thing that is very important in mathematics is to understand what a set is. And we talk about a set as a collection of objects. So a set is a collection of objects. So that's something that is very important to keep in mind. And we could talk about different sets. We talk about the whole number set. So the whole number set would include things like, if you write it like that, you could write 1, 2, 3, and so on and so forth. You can also think of whole numbers, of natural numbers, as having their own set. So whole numbers would be 0, 1, 2, 3, and natural would be 1, 2, 3. So those are examples of the different types of numbers. On a number line, which is just something that we use in many parts of mathematics, we have 0, and then we have 1 and 2 and 3 and so on and so forth. This is an example of how a number line can be used. It's something that you can look at on a meter ruler, for example, to see the whole numbers on the number line, or you could use it to see measure things, of course. So in mathematics, we're measuring things, and that's very important. So we're going to be looking at a few examples here that will be helpful on examples that will be helpful when you go to do the problems. The problems at the end of the book, we have problems that are asking you about basically graphing whole numbers on a number line. So if you have a number line and they ask you to graph whole numbers, right? All you would need to do is just close that loop there. So for example, I have put 1 on this number line, and that could be 3 on the number line here. And it's very important to know how to do that. So the first part of your assignment deals with working through those. And we'll do more examples. This video is just introducing you to the concept. So let's talk a little bit more about some of the concepts you're going to learn from this chapter, and then we'll move on to some practice problems at the end of the book to help you work through that. So you need to know how to graph whole numbers on a number line. You also need to know how to order. So you need to know how to graph whole numbers on a number line. It is very important that you make sure you know how to, when you think of, what we're discussing, it's very important that you have a good notebook that you can use to take notes, and you do your best to write the date in the notebook and then the topics as we learn them, as we talk about them. So make sure you remember we're going to talk about graphing whole numbers, and then we're going to talk about ordering whole numbers, right? Not all numbers are equal in value. Some numbers, for example, we say 5 is less than 10, right? That's just a symbol here when we talk about less than. So we want to make sure we're comfortable with ordering numbers. If I gave you a number line and I told you to order the following numbers, you should be able to put them in order from the smallest to the biggest. So ordering numbers is important. Comparing numbers is important, right? If you know how to order them, then you should be able to compare numbers as well. And that is also from section 1, chapter 1. So these are some things to keep in mind so far. We've talked about whole numbers. We've talked about graphing whole numbers, ordering whole numbers, comparing whole numbers. And now let's look at expanded notation. And when you get to the practice, you will have a lot of practice to review these principles. Expanded notation. If someone were to tell you that a certain number, 234, okay, that's a certain number, and they tell you, hey, can you write that in expanded notation? You would essentially be saying you have 2 hundreds, right? 200. You have 3 tens, and you have 4 ones. So we have 30 there, and we have 4. If you add these up, you get the same number that we started with. So if you add it up, you get the same number you started with. We've written it in expanded notation. In order to do that, we needed to use place value. So with place value, we understand that there's the ones place, there's the tens place, there's the hundreds place, there's the thousands place. And for more of these, please look at your Tools for Mastering Mathematics booklet that came with this course, and you would see that we give you that for the place value up to very large numbers and also for very small numbers. So you can look at place value section of your Tools for Mastering Mathematics reference booklet, and that reference booklet will be very helpful as you go through this course. Now we're going to talk about, so we can look at place value. Your book talks about this on page 5 also. But let's go ahead now and move on to the next concept, which involves rounding. So we've talked about ordering numbers, comparing numbers, expanding numbers, and then rounding whole numbers. That's very important as well. Please know that you can always pause this video and review what we've discussed. You don't have to watch it all, and you can pause and then make sure you've taken notes and then go back and continue. So if I give you the number 87 and I ask you to round up then to the nearest 10, then you would be rounding it up to 90. And that's because this 7, which is right next to the 8, that 7 is greater than or equal to 5. When that happens, we round up. So we need to remember there are situations where they ask us to round up or they ask us to round down. Somebody asks you to round 203 to the nearest 100. You would be going to 200 because this, well, first of all, the number right next to the 2 is 0, and then you have your 3, which is in the ones place, but the number in the tens place is less than or equal to is less than 5, so therefore we round down to 200. So that's very important as you remember your rounding principles. So to round a number to a particular place, we usually mark the place you wish to round to. This is called the rounding digit. So you have the rounding digit. That's one thing to keep in mind. And then you also look at the number next to it. So the test digit. So this is the digit to the right of the digit that you were trying to round to. And that's where you see if it's greater than or equal to 5, or if it is less than 5. That's very important. So remember, you can be greater than or equal to 5. You round up. or you can be less than 5 and you round down. That's something to keep in perspective. They can ask us to round to the nearest tens, to the nearest hundreds, and so on and so forth. Those are important things to keep in mind when they ask you to round. The symbol that you'll be seeing in this book, which is different from an equal to, so more like a squiggly lines here, that has to do with approximately equal to. So that's approximately equal versus this is saying equal. So the equal sign is very powerful. It really says the thing on the left of it is equal to the thing on the right of it, but approximately is giving you just an approximate value, and you can look up the word approximate if you want to do some vocabulary search there. The last thing we'll be doing is on tables and graphs. Tables and graphs. In mathematics, we talk about tables and graphs. With tables and graphs, we basically have to recognize that you would have two dimensions here. You would have a y-axis, we'll just call it that for now, and an x-axis. And most times you would notice that the x-axis deals with the independent value, so like time. In most of these examples, you will see that we're asking you for something that has to do with time, and then a certain quantity goes on the y-axis. So there's line graphs and there's bar graphs. Those are the two types of graphs. So let's remember that. There's line graphs and bar graphs. And in our practice problems, we'll be seeing some of these where we'll be asked questions with regards to graphs. Thank you for your time. We'll go ahead and dive into some practice problems in the next video.